Hey, and we're back. Can you believe that? It feels like it's been only minutes for me. Has it been days for you? Oh, but it's good to be doing math again. Well, this lesson really is just a continuation of the previous lesson, and we're still going to be multiplying polynomials. What we're going to do is just show you how to handle multiplying polynomials when it's not just a binomial times a binomial. So a binomial times a trinomial times a trinomial. So we're just going to kind of expand what we did last time, talk about a few little details. So here's what I want you to do. All right, I want you to do, can you guess it? Yeah, that's right. Those first three warm-up problems. Now, I'm gonna give you a little hint here. Notice that we just gave you, all right, the problems here, and so I'll get you started just as a refresher in case it has been days and days for you. For me, it's been like 5 minutes. But really, what we want to do is do the area model. So remember, just give this a shot. All right, by drawing a box. Hopefully, you can draw a box a little bit steadier than me here to represent your. Oh my goodness, this is just really, really bad. So let me just do this. Let me be smarter about this. I don't know what's happening. No, come back. I'm going to be a little bit smarter because I have this, and I'm just going to pick this guy, and let's see. And sometimes you just have to be a little bit smarter, and or maybe not. All right, so, all right, and then, so yeah, so draw, maybe you will be better than me, but just give it a shot by drawing that area model first, right, and give those a go. And we'll have a little Hamilton here to give you something to think about while you take your shot. All right, so hopefully you're back with us now and you went through this now. On the first two here, I think you probably did a really good job. All right, and so what I'm going to do is I'm actually going to cut to this slide right here. All right, and show you the work here, just to speed up the process a little bit with everything that we're doing. Now, when we look at what we have here, right, you label everything. Your first product should have been 2x squared. Your next product should have been a positive 2x, a negative 3x, a negative 3. And then notice once again, your like terms are just these two guys here in the middle. All right, and so when you combine those, you get 2x squared minus 1x minus 3. Very similar problem for the second one here. So x squared minus 3, x cubed positive x, and then once again, remember when we multiply variables, we add the exponent. So you should have gotten x to the fifth, negative 3x cubed, positive x squared, or excuse me, positive x cubed here, and then a negative 3x. Now notice once again, our like terms are just these two guys here in the middle. All right, so x to the fifth, 1x cubed minus 3x cubed is negative 2x cubed, and then you bring down the negative 3x. Now, the last one may have given you a little bit of a challenge, but you have to think about what this means up here, and it's really just a simplified version of what we've been doing, right? So if we have x minus 1 squared, and you can see I wrote it down there, that just means we'd have x minus 1 times x minus 1. And this really gets back to what we talked about yesterday when we talked about x squared, right? So x squared was just x times x. So sometimes they simplify, instead of writing it out x minus 1 times x minus 1, they'll write it out, right, in simplified version using this 2 there for what you need to do. All right, but then notice it would be x and then minus 1, and x and a negative 1. Now, if you want, you can pause the video and give this one a shot, or you can just kind of go through it with me here. All right, x squared, negative 1x, negative 1x again, and a positive 1. And then once again, those like terms are right here in the middle. So bring down the x squared, negative 1, and negative 1 is a negative 2x, and then that positive 1 is that positive 1. So that's really a recap and a refresher of what we did In the last lesson, maybe yesterday for you guys, maybe 10 minutes ago, maybe a couple days ago, but for me about 15 minutes ago probably now. All right, so I'm going to go back to our sheet here and really talk about what now we're going to do. And so if you look at number one here, right, so really what we have is we have a binomial like we did yesterday, but notice now we have what we call a trinomial because it has three terms. And so notice now we have a 2 and a 3 here. So 2 times 3 is 6. So that means we're going to have 6 pieces once we get through with all of our multiplication. And so now we have a 2 by 3 grid instead of a 2 by 2 grid, all right, to record all of our work. But the process in and of itself is pretty much the same. So I have x plus 1, so I'm going to put the x here. I'm going to put the positive 1 here. I have x squared plus x minus 1, so I'm going to put the x squared here. I'm going to put the plus x here, and I'm going to put the positive 1 here. All right, and then it's really the same thing that we did yesterday. I'm just going to go through and find the area of each box. So x times x squared is x cubed. X times x is a positive x squared. And then x times 1 is a positive 1x. 1 times x squared is 1x squared. 1 times x is a positive x. And then 1 times 1 is positive 1. Now, once again, if you look, very similar to what we talked about yesterday. If we write everything in descending powers of x going left to right, and descending powers of x going down, what happens is all of our like terms end up being on the diagonals here, which makes it really easy for us to combine like terms. I have our 1x cubed there, so I'm just going to bring that up right here. So we have that 1x cubed, and then I have x squared plus x squared, which would be a positive 2x squared. All right, and then another x plus x, and that would be a positive 2x. And then I have my single constant right there, nothing to combine it with, so I'm just going to write it right there. And so there's our answer for the first one. And you can see it's very, very similar to what we did yesterday, just more. All right, so once again, go ahead and pause the video, and here's what I would like you to do. I would like you to give problems 2 and 3 a shot here. Give those a go, and we'll see how you do. All right, so once again, hopefully you have finished examples 2 and 3. And so once again, just like I did before, I'm going to click over to the answers here just to save time so you don't have to watch me write everything. All right, and so once again, if you notice, I wrote everything in descending terms of x over the top here. All right, everything in descending powers of x here. Negative 4x cubed is your first product. 6x squared, negative 10x. Then a positive 2x squared, a negative 3x, and a positive 5. And really, most of the time, the two issues are either a sign mistake, so for example, not doing a negative times negative is a positive, or, all right, forgetting to write the correct exponent. And then once again, you can see that by doing that, all of our like terms are on the diagonals. So your final answer should be negative 4x cubed plus 8x squared minus 13x plus 5. All right, very similar problem here. So x squared plus x plus 1, x squared plus 1. Now, we just have to be careful that we don't always have like terms, and they end up sometimes not being on the diagonal. And here's what happens. Notice we have an x squared, an x to the first, and then a 1. But here we have an x squared, and we're missing a term because we go right to the constant term. And so what happens now is now my like terms are not necessarily on the diagonal. So while this works most of the time, it's not an always case. So don't just look at this and assume that they're like terms. All right, so do pay attention to that because we do get in the habit, because this is the case most of the time. But as you can see from this example, it doesn't always happen. So notice there's only 1x to the fourth. There's only 1x cubed, but now my like term are right here. So they're not quite on the diagonal. Then x squared plus x squared is 2x squared. Then I have x plus 1 plus 1. All right, so here's what I'd like to do. All right, let me go back to this sheet right here, and I am going to just really quickly, all right, run through example 4 here with you, and then I'm going to have you do a couple more problems on your own. All right, so then once again, I'm going to go x squared. Oh, my thickness is off here. So go back and do this again. And then I'm going to do the minus x here, and the minus 1 here. All right, now notice this is 3 across, and then I also have 3 down. All right, like this. And notice I have 3 things times 3 things, so I'm going to have 9, all right, in my box here. So x squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times negative 1 is negative x squared. Okay, 3x times x squared is 3x cubed. 3x times negative x is negative 3x squared. And then 3x times negative 1 is negative 3x. Negative 5 times x squared is negative 5x squared. Negative 5 times negative x is a positive 5x. And then negative 5 times negative 1 is a positive 5. Now notice, we're not missing any powers of x here. We're not missing any powers of x here. So our diagonals are like terms like before. So if I write all those out, I would have x to the 4th. Then 3x cubed minus x cubed would be a positive 2x cubed. Negative 5x squared minus 3x squared minus x squared would be a minus 9x squared. And then 5x minus 3x would be a positive 2x. And then we just have that lonely little 5 right there. All right, so here's what I would like you to do. Once again, pause the video. I would like you to do 5 and 6, all right, and see how you do. All right, so, and once again, just to save a little bit of time, well, there's my cursor. I'm going to flip over here so you guys can see how you did. All right, so there's all the work. If you need to pause it and kind of check your work real quick, do that. All right, but I have all the work filled in for you. And you can see on number 5, your final answer should be 2x to the 4th minus 16x cubed plus 29x squared minus 28x plus 6. All right, when we look at number 6, you can see that your final answer is 12x to the 4th minus 5x cubed minus 17x squared minus 9x minus 6. All right, we're just about finished for the day. I'm going to show you a little bit of setup, but I'm not going to do the entire problems because I want you to do those. All right, so I'm going to show you just a little bit of setup on these problems. And then what I want you to do, all right, is finish these problems, and then I want you to pull up the notes answer sheet and go through those and check your work, all right? So I'm not going to go through all the answers in this video, all right? I'm going to show you some setup, make sure you understand kind of how to do the work. Then I want you to do the work, do 7, 8, 9, and 10 completely, pull up the notes answer key, check your work, and then let us know if you have any answers. Now, so part of this is 2 different things on the setup. One is, all right, recognizing, okay, this power of the exponent and what that does to my initial part of my problem. Now, remember that x minus 3 cubed means that I have x minus 3 times x minus 3 times x minus 3. All right, so the first thing is we have to write this out. Now, that's the first piece. Now, the second piece is that this is really a 2-part problem. So the first thing we have to do is x minus 3 times x minus 3. So you're going to have to come over here and draw your area model. All right. And then I'm going to have x minus 3. Maybe. There we go. And let's see if it'll recover here. X minus 3. And so I'm going to do this product. So x times x is x squared. X times negative 3 is negative 3x. negative 3 times x is negative 3x. And then negative 3 times negative 3 is a positive 9. Now, once again, if I combine like terms, I get x squared, and then minus 6x, and then plus 9. So now I know what this is. So x minus 3 times x minus 3 is x squared minus 6x plus 9. And then it's times x minus 3. And so notice by doing this, this is now just like what we were just doing. So now I have a binomial times a trinomial, and now that's why it's a two-step problem, because now you have to do another multiplication problem, all right? And so now we have to do our 2 by 3 grid here, right? And we'll have our x minus 3 here. We'll have our x squared minus 6x and our plus 9 here. And then it's just like what we are doing. So I wanted to show you kind of that setup and how you go through it. You can see number 8 is very similar. All right, and then I'm going to jump down here to 10. And so notice 10, when we have 3 binomials, you have to multiply the first 2 binomials together, just like we did here, get a trinomial, and then multiply times x plus 2. All right, my friends, it was good spending some more time with you today and got to listen to a little bit of Hamilton. All right, so hopefully you can give this a shot. Let us know if you have any questions. Take care of yourselves. We'll talk to you later.